Ladies and gentlemen, well, we will have a talk about what you need to do to make your database, as the advertisements say, unbreakable. And, well, maybe Alexander can tell us a bit more about how robust the Oracle database actually is.
Okay, good evening. Before we start, a quick question. Who in the audience has experience with Oracle? Perfect, I hope good experience. I tried to compose all the latest and also the current trends in Oracle security, and we start with the past. A few years ago, Larry started his Unbreakable campaign. And Oracle made the experience, if you claim to be unbreakable, then a lot of people try to prove that you are wrong. And the experience was that the number of attacks increased by 3 times because everyone wants to break Oracle. But Oracle is also quite complex, so in the past only a few people were focusing on Oracle security. For example, David Litchfield, Cesar Cerudo, and so on. And 3 years ago, one of the milestones in Oracle security was an unknown Russian hacker, and this guy was selling a tool to unwrap PLSQL packages. And this was really, really useful because now it was possible to analyze the PLSQL packages, which are normally wrapped, a kind of encryption, in plain text. And as a result of this small tool, the number of vulnerabilities in PLSQL was increased by 10 times. And this is a hard copy of this unwrapper, so now it was possible to unwrap the PLSQL packages and then search with a simple tool like grep or text editor for SQL injection vulnerabilities. And the result, a lot of people reported hundreds of vulnerabilities, and Oracle created a package called DBMS Assert. And this package, DBMS Assert, is responsible for input validation. And the first time this package appeared was in Oracle 10G Release 2, and this package was backported to Oracle 8i till 10G Release 1. And in the last 3 years, Oracle fixed more than 1,500 vulnerabilities in their PLSQL code. So you can see the database, a database which is unpatched for 2 years, has 1,000, 2,000 vulnerabilities in their system. And these are only the vulnerabilities in the PLSQL code. And Oracle made also some progress. And nowadays they're using the source code scanner from Fortify. Fortify extended the source code scanner, so Fortify is now also able to find SQL injection vulnerabilities in PLSQL. And nowadays it's no longer the game security researchers versus Oracle developers, it's more the game, can you find vulnerabilities which are not identified by Fortify? And this is still possible because the Fortify developers do not have such a deep knowledge in PLSQL programming. But nowadays, 2007, 2008, the big time of SQL injection in PLSQL packages is over. Because Oracle did more or less a good job, there are probably 30, 40 vulnerabilities left. But you should always keep in mind, one vulnerability is sufficient to overtake a database server. So if you have one incorrectness, security vulnerability in a PLSQL package, you can overtake the database server. Later I will show some example. Some packages are still buggy and not fixed because Oracle needs a lot of time to fix vulnerabilities, sometimes between 2 and 3 years. But the big problem nowadays is that most of the PLSQL code is no longer written by Oracle itself, it's coming from customers. So from my experience, if we do source code audits from customer code written in PLSQL, it's completely buggy. It has the same quality as Oracle 3-4 years before. And one of the reasons, a lot of database developers never heard of the term SQL injection. Even in 2007, they are focusing on business logic and they never heard of security. Security for Oracle developer is often something network stuff, buffer overflows, and so on. And if a developer never heard of SQL injection, he develops everything unsecure. And a non-Oracle developer does not have the pressure to fix the vulnerabilities, because if you find a vulnerability, you send information to the Heise news ticker or to Bugtrack or something like this, and then Oracle must sooner or later fix the problem. If you find a vulnerability in a custom application, nobody takes care. There's no pressure to fix these vulnerabilities. From our experience in many companies, we are able to find a lot of vulnerabilities. And from the attacker perspective, instead of exploiting vulnerabilities in Oracle itself, they're exploiting vulnerabilities in the customer code. Because for the hacker, there's no difference if he becomes DBA via Oracle code or via customer code. And also an important step was this year the Black Hat Federal. At the Black Hat Federal, David Litchfield published a new technique which allows to escalate privileges with the lowest amount of privileges. And he's using a special package called DBM SQL, which is granted to public. And instead of using a procedure, he's using a cursor. And even if this bug was never accepted officially from Oracle, it's now fixed in Oracle 11g. And here's an example. So here with the declare, we have this dbms SQL.pass, and here we declare a cursor. And this cursor contains the command grant DBA to public. And if a cursor is open, it's not automatically closed by Oracle. So in the next line, sys kupw worker main, we can inject this cursor. So, 1 second. So we inject this cursor here. And after executing this piece of code, we have DBA privileges. To get the DBA privileges, we must run the command set role DBA, so our current session has DBA privileges. And in the next step, we directly revoke DBA from public again. This means nobody else has DBA privileges, but our current session has still DBA privileges, but this is not visible in any table. So the DBA is not able to see what session has DBA privileges. And the big advantage of this exploit technique is it's not necessary to have create procedure privileges. So just to create session, the lowest amount of rights in Oracle is sufficient to exploit this. And this is without IDS evasion, because you probably know that everything in Oracle is sent in clear text over the network. And some intrusion detection systems are looking for strings like KUP $worker or grant DBA to public. And here we are using a simple Caesar chiffre to encrypt our exploit. So here we have translate, and this string is translated with this key. So here you see grant DBA to public minus minus. And then in the database server itself, it's decrypted and then executed. So nowadays, most of the systems can still be overtaken. In the future, what will happen? It's really important for Oracle customer to train their developer and to analyze their code, because most of the code is buggy. You can do a manual source code auditing, or you can use a PLSQL source code scanner. For example, from Fortify, or we have our own PLSQL code scanner. Pardon? Where was the question? Okay, no question. So in the future, hackers can use automatic tool to exploit all the vulnerabilities. because nowadays it's quite easy because everybody has access to the Oracle packages, but for custom code, you don't have access to the packages. So you must use automatic tools to do the exploitation. And it's not really difficult to do this. So you can just, if you know a function or procedure accepts parameters, then you can inject some special strings to escalate privileges. And it's not really difficult to do something like this. So this was everything related to PLSQL code. Another interesting thing many people are currently not aware are database rootkits, because it's possible to have rootkits in the database as well. And on April the 1st, I presented the idea of migrating rootkits to the database world. But my problem was it was the 1st of April, so a lot of people thought it's a 1st April joke, but that was not the case. And it's possible to hide users, processes, jobs in the database. Because the database is nothing else than an operating system. You have jobs, you have processes, users, and so on. And instead of putting the rootkit in the operating system layer, you can put it in the database. The big advantage, these database rootkits are platform independent in most cases. So it doesn't matter if it's running on Windows, HP Unix, Linux, Solaris, and so on. And I will show a short example how you can implement a rootkit in Oracle. Oracle is quite an old application, so Oracle decided 20 years ago that users and roles are stored together in one table called sysuser$. And to distinguish between users and roles, the user have a type number, a flag called type number, and this flag is 1. And roles have the flag type number is 0. And to make access easier, Oracle has two views, DBA users and all users, and also some public synonyms for this. And the problem is everybody is using the view, and we can now modify the view by just adding something like end uname not equal hacker. This means the view shows everything except of the user hacker. And if you do this, this user hacker disappears in all the tools, so Enterprise Manager, Toad, and so on. But Oracle itself, the database, is using, for authentication, is using the table. So you can still log in with the user hacker, but you are not able to see this user. The side effect, the disadvantage, you modify a view, so you can see this view, here was it, so you can find this change in the data dictionary. So it's still possible, 99% of the DBAs would never find this, but it's still easy to track. And here I also put some simple PLSQL code to generate a rootkit. So I'm using so here I create a text file, rk_source, and then I select the DDL statement from the view all users, and in this DDL statement I replace where with where uname not equal hacker. And the result of this DDL statement, it's create view all users and so on, is written in the file rk_source. And we do the same for the view DBA users. Then we disable the spool file, create our user hacker with DBA privileges, and then we hide this user. So with a few lines of code, you can do this. And I presented this 2005, so 2.5 years ago. 1 year later, I presented the second generation, where you can implement rootkits in the database without modifying objects. So even if you have a checksum tool checking your objects, you're not able to see these changes. And also other people released some simple rootkits. For example, the 2600 magazine published also a rootkit hidden in a PLSQL package. This year in January, the company Argen ISS from Argentina was also starting selling a commercial rootkit, a commercial database rootkit for Oracle and Microsoft. Because all these rootkits, it's not only a Windows Oracle problem, it's a problem of all relational databases. And Cesar, they released a commercial rootkit also with a graphical user interface, where you can also create invisible users, export a database, and so on. And here on the left side, you see the owned databases. At the moment, I don't see a market for commercial rootkit, but Cesar had a different opinion. And after installing this rootkit in the database, the rootkit is opening a separate port, and you can send command to this port. And the port is accepting data, and you can drop user, create user, export files, and so on. And also this year, some information was published about database rootkits. In October 2007, Paul Wright from NGS released a white paper about sysdba rootkits. It's possible to generate invisible sysdba users, which are only available in the Oracle password file, but no longer in the database. Another idea, David Litchfield presented in Vienna at the DeepSec conference, a third generation memory rootkit. So instead of modifying objects in the database, he's directly modifying function calls in the memory. So there's no change in the objects. And he showed also a possibility how to create an invisible user by updating a value in the table sysuser$. So instead of modifying the view, he's changing just a value in this table. And if you change the number of table space, which is also part of the sysuser$ table, then this user disappears from all the views, DBA users, and all users. But David underestimated the power, and in the next slides I will show that you can really create really difficult to find rootkits. Because in Oracle, here this is the rootkit, which is you cannot find with normal techniques. In this table, sysuser$ I mentioned already, there are users and roles. And by default, Oracle installs a role called Java deploy. And this Java deploy is normally installed in every database. And now we can convert such an existing role into a user just by updating the type and assigning a password. The next step is we grant DBA privileges to the former role, and then we flush the shared pool, because Oracle is always working with a dictionary cache. So all the objects, all the users and roles are not taken from the table, they are always taken from a memory object. And if we run this alter system flush shared pool, we can reload this memory. And due to the fact that we reload this object, our user is now active. So you can now connect with Java deploy and the password Alex. The next step is we change the type back to 0. This means if you do a select statement, Oracle shows that you are using a role. So you can still connect, but Oracle shows it's a role. The problem, if you shut down the database, the dictionary cache is lost. That's why we need a shutdown trigger. So every time we shut down the database, we change the type back to a user. And we need a log-on trigger. So the next time the database is restarted, we hide our changes. So if you enter all these statements and the DBA looks up, is there a user? Nobody will see the user. Even if you compare sysuser$ and DBA users, you will not see a change because you have no access to the data dictionary cache. And you can do a lot of nasty things by just modifying data. So in the future, more and more people will think about implementing rootkits, coming up with new ideas. And as I mentioned already, the rootkits in the database are platform independent, and there will be more advanced in the future. Nowadays, auditing becomes also more and more important, especially in bank, insurance companies, and all these paranoid customers. And in the past, most people said auditing is slow. We are not using auditing because it's too slow. And another problem nowadays, people believe if they are using auditing, everything is audited, which is also not the case. Because there are so many possibilities to avoid auditing, and most people are not aware of this. And there are also bugs. In my opinion, nobody ever have checked the audit functionality from Oracle, because some of the bugs are so obvious that I'm wondering nobody reported them. And in my opinion, the design is really poor. Problem number one, in Oracle auditing, some really important tables cannot be audited. For example, you cannot audit changes on the sysuser dollar table. If you try this, you get an error message, object necessary for warm starting database cannot be altered. So you are not able to catch someone changing the user type. It's not possible. Second problem is this data dictionary caching. Oracle is doing something else. If you look up into the table from system objects, this doesn't mean that Oracle is using the same data, because Oracle someone could reload something. It's even possible that a user which was deleted from the sysuser dollar table can still be used for accessing the database. That's also possible. So even if it's physically not available in the sysuser dollar table, you can still connect to the database because it's still present in the dictionary cache. Another problem with auditing is, for example, if the database, the create user operation is audited, then it's quite easy to bypass this because we can just change the type. So one possibility to create a user, if you don't have create user privileges, and if create user is audited, is you create a role and change the update type, this type. And that's the same trick. So you created a user, but Oracle is not aware of this because it's just a role with an update. The typical answer from Oracle, if you talk about this, is if you do this, it's not supported from Oracle support, and you are losing support. But in this case, it's bad luck for you, because one is you have a hacker in your system, and the second, your database is no longer supported. But from my experience, Oracle support will never find out that someone is using this. Another problem in the Oracle audit concept is the fact that Oracle has some functions to insert, update, and delete data from the audit trail. I'm not sure if this is available in Unix, a function where you can delete data from syslog, but I think it's a bad idea to offer the possibility to delete data from the audit trail, because what's the worth of this functionality if you can remove this? And the reason is Oracle is using this internally to remove entries from the audit log. So from my experience, with auditing you can catch a little bit, but not everything. And if you have a clever attacker, it's quite easy to avoid Oracle auditing. Now we are talking a little bit about Oracle customers. In the past, they said, we are safe. Our database are so deep in our network, nobody will find these data. Nobody will steal data. We have all trustworthy employees. All the DBAs are good and nice, and most of the DBAs, or all the DBAs I know so far, are good and nice. All external companies are nice and friendly, and we do not have any valuable data. That's the typical sentence. I see we have some customer from the past here. Nowadays, this changed a little bit. So they say, we are safe, but we are not 100% sure. That's why from time to time, they are doing audits or something like this. They still believe all the DBAs are good, but we should monitor them just to be on the safe side. And a lot of companies are still thinking about outsourcing databases to India or other warm countries. And in the meantime, they realize that some of the data is important. And one of the reasons is also some of the regulations like HIPAA, SOX, and stuff like that. In the future, customers will see, okay, we have a small problem with our Oracle databases. We do not trust our DBAs because they are changing every 1 or 2 years, and we must monitor them. I guess auditing and monitoring in a few years will be default out of the box. People will realize that data is important, and if someone steals your database, this can be really expensive. And also if you must follow PCI DSS, this can be a killer for your company. So if someone steals all your credit card numbers, this can cost you your company. The databases in the past were really easy to hack. Scott Tiger, System Manager, sys change on install, unprotected listener, no patches, the database with uptimes 2 years. Everybody was trusted and so on. And this Oracle database was hacked in a second. Nowadays, I'm always happy if I do a security audit and I find System Manager or change on install because it's quite rare. Nowadays, the most common user account is DBSNMP. From my experience, most of the system accounts, like sys and system, they have good and strong passwords. So it's nearly impossible to guess these passwords. But one of the side effects is most of the big companies have hundreds or thousands of databases. And as a result, all the password, even if the password is good, is identical through all the databases. So if you know one password, you have access to 1,000 databases in some cases. The big problem even nowadays are user accounts, password is username. For example, you have a project called Crips, then the typical username is Crips, and the typical password is also Crips. And that's even nowadays quite common. So in most cases, you have an unprivileged account, and from the unprivileged account, as an attacker, you must escalate your privileges. 8i and 9i databases are still unprotected because DBAs don't like the password protection. Oracle 10G listeners are secure out of the box, so it's more or less secure. People still don't like the critical patch updates, and so they apply only the regular patch sets, and we have short uptimes. And people also realize that normal security, like applying Unix patches and so on, is important. Hacking is possible, but it becomes more difficult. The easiest way in most cases is if you need a user account, password is username. In the future, we will also still have good and strong passwords, but even then, the password will be the same on all systems. The listeners are protected out of the box, so in most cases, that's not a good way to become DBA. People will do regular password checks. This username equal password will disappear because people are using password verification functions to enforce the company password policy. But even in future, people will not apply security patches because you don't have the time to apply everything. And security becomes more and more important, and people are doing regular audits. And hacking separates the men from the boys. But there are still a lot of possibilities to become DBA. So in the past, typical vulnerabilities in Oracle products were SQL injection, what I mentioned before, buffer overflows if you use long passwords, long usernames, typical stuff. Too many privileges, hard-coded username, default passwords. Nowadays, typical problems in Oracle products are cross-site scripting, privilege problems, and also SQL injection problems in SQL scripts or upgrade scripts. So most of the Oracle upgrade scripts are still buggy, and I will show an example. Here are some of the vulnerabilities which were fixed in the last 2 years. One of the most critical, in my opinion, is the following. By using a specially crafted inline view, it's possible to insert, update, delete data without having privileges on this table. So let's assume you have only select privileges. By using this kind of inline view, you can insert your own row without having the right privileges. Because Oracle is, as soon as you are using an inline self-join, Oracle is mixing the privileges, and as a result of this privilege mix, you have all the rights on the table. One possible way what you could do is, if some of you develop with Oracle, there's a table called dual, and the dual table consists only one column, one row. And with such an insert statement, it's possible to insert a second row into this table. And as a result of this insert, nothing will work anymore in your database, because a select sysdate from dual will return 2 rows instead of 1. And normally you don't have an exception handling for this. That's only one possibility. Or let's assume you have a reporting system where people can only see a report from your salaries, for example. Using an update statement, you can change your salary with, even if you have only select privileges. So this is an update statement, and delete statement is similar. And this was patched with the critical patch update in October. We reported this to Oracle. More or less a similar problem is this one. So we have also a view with an inline join, with a self-join. And if you use this view, you can also insert, update, delete from any table where you have select privileges. And here, Oracle, it took only 19 months to fix this vulnerability. And this was a problem in the Oracle optimizer. So the Oracle optimizer was confused, and this was fixed in October 2007. So if your company, and most of the companies do not have this patch applied, you can still update, insert, delete everything from tables. It's also a nice example about quality from Oracle. If you connect to the database using SQL Plus or OCI or JDBC, Oracle is sending the alter session set NLS statement to the database. And this statement is coming from the client. And normally this NLS is for the national language settings, so you set alter session set NLS German, Germany. And the problem was, this statement was coming from the client, and the second problem was, this statement was executed always with sys privileges. And I'm not a big reverse engineering expert, so I used the poor man's reverse engineering tool, UltraEdit, and I did a grep on the Oracle DLLs, where is this alter session set NLS coming from. And then I replaced this alter session with grant DBA to public, minus, minus. And then I saved this file to my hard disk, and as a result, we introduced democracy in the database, because everybody is equal, because everybody has DBA privileges. But from my experience with companies and large companies, they don't like democracy. They say it's anarchy. Everybody can do everything. So to fix this problem, you should apply the January 2006 CPU or patch set 10.202 or later. But especially if you do a security audit and you find an older database, especially the 8.0 and 7 databases, there are no patches available. You can overtake them just with 1 second. And David released in January this year a small tool with the name Aura alter session. And with this small tool, it's no longer necessary to patch the DLL, just pass the statement in the command line, and then you can overtake a server. Security bugs in the future are more exotic because the simple, or most of the simple bugs are already reported. In future, we will see problems with the query optimizer, because that's a big nightmare. It's the oldest part of the code in Oracle. We will see locking problems. For example, in Oracle and in most of the relational database systems, you can run the statement select star from table for update. And if you inject, for example, this statement via your web application, Oracle is locking the entire table. So nobody else can modify this data or insert a new value. So if you do this via web application, you can lock the entire system. And this for update statement, or this extension for update, works also if you don't have update privileges. Because even if you have only select privileges, you can lock a table. And then you can create nice deadlocks. But at the moment, nobody focused on this problem. Then we will see the abuse of Oracle features. I will show some examples on the next slides. Client-side attacks, it's probably one of the easiest way to become DBA in Oracle, even if all the patches are applied, and also everything related to auditing. That's a nice little feature from Oracle called transparent data encryption, because everybody, especially the auditors, demand encryption. So Oracle said, we learned our lesson, and they implemented their own encryption technique. And this transparent data encryption adds transparent encryption on the database level. So you can directly encrypt a table. And Oracle itself is doing the key management, and all the keys to encrypt and decrypt the data are located on the file system, or in 11G it's also possible to put these keys on a piece of hardware. So if someone steals the hard disk or the backup tapes are lost, they cannot decrypt the data. And also the archive, a hardware security module. Or the question was, is it a hardware security module? And yes, it's this typical security modules. And also the archive and redo logs are encrypted, so in case that someone can get the archive logs or redo logs, they're encrypted. And it's quite cheap, costs only $10,000 per processor. So if you have a 32 processor machine, it's cheap. And especially auditors, they like TDE, because you can say, okay, our credit card data is encrypted with TDE, with AES 256. The problem, this T means transparent. So if an attacker comes from SQL or from the application layer, it's transparent, so the encryption is not visible. That's why it's useless. And the first time I analyzed TDE, I said, okay, it's a backup protection in case someone steals your backup tapes, and it's useless. And then I found some nice side effects. One side effect is TDE can help an attacker to find interesting information. For example, a SAP system has up to 60,000 tables, and with one table, with one statement, you can select all the tables which are using encrypted data. So for example, here we have, almost too fast. So from 60,000 tables, we know, okay, we have one table credit card, and we directly know where the interesting data is. And because it's transparent, we can just say select star from credit card, and then we have everything. And TDE is a new feature of Oracle 10G Release 2, and it's installed by default, and it's not possible to disable this feature. But you're not allowed to use this, because then it's a license violation. And to use this feature, you just run the alter system command, set encryption key, and then you create a wallet, and the password for the wallet is this CCC password. And now you can start encrypting tables. You can encrypt new tables, or you can alter already existing tables. And the next time you start a database, you must open the wallet, and to open the wallet, to be able to encrypt the data and decrypt the data, you must know the password. Okay. Now we make a short scenario. I guess some of you are living or staying in a hotel, and if you travel, you have often your passport and your ticket in your hotel. And most of the hotels have these nice little safes somewhere hidden. And what happens if you sit here in the presentation, if the maid is taking your passport, your flight ticket, and puts this into the safe of the hotel. And then the maid is locking the safe and puts a note on it. Okay, for 500 euros, you get a pin. Now, after this presentation, back to the hotel, you know your plane is leaving at 9 o'clock or 10 o'clock, and then you find the note. Then you have the problem. What are you doing? Do you call the police? Then you must wait a lot of hours, you miss your plane, you need a new ticket, or do you pay the 500 euros, which is cheaper? The problem here, it's quite simple. In the hotel, you just call the reception and you say, okay, I need the backdoor for the safe. I locked accidentally something in the safe. That's not a problem. But we can migrate this concept into Oracle. Because as soon as you have DBA privileges, you can enable transparent data encryption. And just submit this alter system command. The next step is you start encrypting important data. But because this is transparent, nobody sees you don't have an impact on the application because everything is working as long as the database is up and running. And then you can write a database job, or the next time they shut down the database, and if they want to restart the database, the data is still there, but it's encrypted, but nobody has the key. And then you send a nice little email to the CEO and say, okay, just pay this money. The big advantage from the attacker in this scenario, it's not necessary to transfer 10 terabytes of data outside of the company. The data is still there. The only thing they need is a password. And without the password to open the wallet, your data is lost. In all the archive logs, video logs, everything is encrypted, so what can you do? And the problem, what I know so far, there's no backdoor in transparent data encryption, so it's better you pay the money. If you call the police, this takes ages, but normally a database, you cannot wait ages on your main production database. So in most cases, people will pay. Another scenario, it's not only a hacker. Also, if you plan to lay off DBAs, a DBA could encrypt the data, and he's responsible for starting and stopping the database, so everything is working fine. But if you fire the DBA, then your data is also gone. And the problem in Oracle, it's not possible to disable this feature. So as soon as you have a 10G database, everybody could do this. And because it's not possible to disable it, one workaround, there's an init-aura parameter called compatible. And if you set this switch to 10G, 10G release 1 or 9, then TDE was not available, and then you cannot set this. Or you can open your own wallet, because then the attacker cannot create his own wallet if there's already a wallet there. But in this case, you must pay the license, 10,000 US dollar per processor. Another way to become DBA. Very often the easiest way is the PC of the DBA, because the DBA can directly connect to the database, and it's the easiest attack. We don't need a password or a user account. And the easiest way is sometimes a USB stick, just throw them away on the parking lot. And the The reason is Oracle has two files called login.sql and glogin.sql. And these files are located on the workstation of the DBA. And the content in these files is executed after you connect to the database. So if you put a drop user system cascade into this file on the DBA workstation, this is executed after the DBA enters username and password. And it's even better, you can put a HTTP call. So Oracle is downloading the content from a website, and this content is executed against the database. So this file could be empty for 1 or 2 months, and then just switch the web page, and then you can overtake the system. I talked with Oracle about this problem. Their answer was every DBA knows these files, and every morning before connecting to the database, if you have DBAs here, are you doing this every morning? No, I never met this. So they said it's not an Oracle problem, it's a problem of the DBA, but also other tools like Toad, SQL Developer, PLSQL Developer, they have similar problems. And here an example, to get rid of terminal output, we set term off, then we create a user with DBA privileges, and then we set the terminal on. So against every database we are connecting to, this user is created with the password. And there's no output, so after 1 or 2 weeks we have a user on every system. Or we can put the HTTP call, and on this web page we also disable the terminal output. And then we have this nice little handy feature called host. With host we can run operating system commands. So we are leaving SQL Plus, and from SQL Plus on the DBA workstation we start TFTP, and we are downloading a file evil.exe on the workstation of the DBA. In the next step we execute this file we downloaded before, and then we create again a user. So this is also possible. It's also a new technique. You can also put shellcode in database objects. And in some circumstances, this is executed. But normally all the shellcode or all the objects in the database world are restricted to 30 characters, so we need short shellcode. And here is an example. If you create a table, most people just enter create table orders without using double quotes. And in this case, if you create an object without double quotes, Oracle is converting the name orders into uppercase. If you use double quotes, Oracle is preserving the spelling. So here you have a table orders with a capital D. But most database developers, I know, they are not using double quotes. And now we can, for example, create such a table. Create table script alert high script. This is a valid table name. And I found also some web applications. If you start a web application and you display the name of the tables, this happens. And the DBA Connect, for example, was one of the applications vulnerable against this. So if your web application is displaying table names, you can put JavaScript, PHP, whatever you like, into this table name. We can also create a table called single quote or1 equal user 12.f1. And f1 is a function, so in some cases, if you use a table, this function is executed and we grant DBA to public. A typical way how DBAs are working, they have a lot of scripts for their daily work, and these scripts are using spool files. And quite often, they are concatenating here the table name. And here they are not doing input validation. So you can use --, you can use union to inject your own statement. And this, the result of this statement is written in this spool file and then executed afterwards. And from my experience, most of the scripts are vulnerable. So you can use Google, for example, search for spool on, spool off, select term off, and most of the scripts you can find here are vulnerable because they are just concatenating the table name without checking if it contains double quotes, single quotes, and so on. For example, if you create a table scott.emp and the DBA is executing this statement, delete from table name, normally he's planning to do a delete from emp. But we just concatenate scott.emp, so we are deleting other people's tables. And these scripts are executed with DBA privileges, so this is also working because privileges is not a problem. Another quite unknown feature is in Oracle and SQL Server, you can use the grant command to create users. For example, here, using the grant connect to CCC identified by PW and so on, is creating a user with connect privileges. So it's not necessary to use create user. And this code is from Oracle. So with this cursor, we are selecting all policy names. Then we are converting them to uppercase, and we append the underscore DBA. And the next step is grant p-role to sys. And the idea from the developer was, if we have a role called test, grant test to sys, test underscore DBA to sys. But what happens if we, here I mixed the presentation. What happens if you create a role DBA to X identified by CCC minus minus? Without the double quote, this parameter is concatenated here, and Oracle is executing grant DBA to X identified by CCC minus minus. Then they append the underscore DBA to sys. And the minus minus is commenting out everything. So by using the script, we are creating a DBA user called X with the password CCC. You can even run operating system commands. For example, it's possible to create such a table. It's a valid table name. And if you are more familiar with Oracle, in one of the previous slides I showed the host command. And the abbreviation for the host command is the exclamation mark on Unix and the $ on Windows. So in some cases, this exclamation mark is executed. So for example, on SQL Plus with $calc or exclamation mark ls, you can run code. And a lot of people are using this. So the typical Google search strings are spool on, spool off, set term on host, and then here we have 33,000 objects. And this script is taken from a website in the internet. And here you see the host command. And at the end of the host command, they concatenate backup, which is a variable and cannot be modified, but then they concatenate the file name without doing input validation. So if you put a semicolon in this file name, you can run your own statements. And this is written into a spool file, and then with this add online backup.sql, the spool file is executed. And then you can start operating system commands. And these scripts are normally executed on the database server. So you can run the operating system commands on the database server. Okay, this was a short summary about different possibilities. Normally I could talk ages about Oracle and security. Questions?
Hi, very interesting talk. Thank you. You mentioned the insider threat and the user management, the Oracle user management. Do you have any experience integrating the database user management with an identity and access management system? And do you think that is something that will make sense, or is there no value in doing something like that?
Oracle has, the question was, is it possible to integrate the user management into some LDAP or something like this? Oracle has also some solutions, but from my experience, most of the companies do not use these solutions because everything becomes much more complex. And the big challenge is how can you get a high available LDAP server, for example, and the problem, if this LDAP server is not available, then you have problems to access your data, and most customers do not like this idea. So from my experience, less than 5% are using these kind of techniques. But in the future, I think this should be mandatory. But Oracle is not interested to integrate their products with Sun or with Microsoft, because their goal is to offer their own identity management. Is this sufficient for your answer? Okay. No more questions?
Hello. Yes, to your right. These tools like Fortify or whatever, are they expensive? Are there any free alternatives, or is this another big item on the big cost?
The question was, is Fortify expensive? As far as I know, yes, it's expensive, but it depends on your pocket. At the moment, I'm not aware about freeware tools, but from my experience, in most cases, a simple grep command and a little bit understanding of PLSQL is sufficient. Because in most cases, I'm using grep or tools like that to find vulnerabilities. Because they are quite typical, you need 10, 20, 30 search strings, and then you find most of the vulnerabilities. Okay, thank you. Okay.